Hello, this is Mighty CS Man, and this is an introduction to CSC 143, which is an introduction to data structures in Java. This video is week 2 on inheritance and interfaces. And if you'd like more information about the rest of the series, please like and subscribe. So just quickly reviewing, since this is really the first big lecture of CSC 143, I wanted to review that 142 and 143 are University of Washington curriculum. They are taught at all Washington State colleges. There are similar introduction to CS classes available nationwide, and we teach our class based on the book Building Java Programs by Stuart Regis and Marty Stepp, version 4. Let me quickly show you where you can get that book online for a reasonable price. There are lots of places that you can get this book, but one interesting option is that there is only one officially available online version of the book, and that is through the website VitalSource. I have no affiliation with it, and I don't get any money from this. I just want to point out that if you want to rent it, you can get it for $35 for 180 days, and that's a great way because it is a very large book, and it's great to be able to, you can actually download it to your computer and use it right there. Let me also point out that, of course, it's available on Amazon. This is the third edition of the book on Amazon. Unfortunately, at this time of year, all the prices are pretty high. Just a couple of weeks ago, you could have gotten a third or a fourth edition for under $30. Now this third edition is available from $34. The third edition is fine. You don't need the fourth edition. I would definitely not recommend the second edition. That's too old. So through any of these options, you can get a hold of the book. So let's move back on to the content. So CSC 142 is all about an introduction to Java programming. If you have not already done basics of Java programming all the way up to using arrays and being able to build a class, then you really need to review that first before participating in the rest of this class. This class assumes that you understand, sorry about the confusion on terms, but you have to understand Java classes, and we're going to be moving on from there. So CSC 143 is all about introduction to data structures. So we are studying this week chapter 9. CSC 142 covers chapters 1 through 8 up to classes. Now starting in chapter 9, we're moving on forward to more advanced topics and classes. This week, inheritance and interfaces. So today, this video is going to cover specifically section 9.1, inheritance basics, hierarchies, how to extend a class, and how to override a method. For this class, I'm going to be using slides created by my dear friend of over 30 years, Dr. Gan. Thank you very much. And she took these slides using materials provided in the Building Java Program book. So it roughly follows the content there, enough that it's going to be useful for us. By the way, notice the joke here, chapter 1001. It's not chapter 1001, it's in binary, right? Which you all learned from 142, so you know that means chapter 9. So inheritance basics. First of all, one thing the book talks about that Dr. Gan didn't put in here was the really genesis of why we have object-oriented programming. I learned originally just regular programming without any object-oriented basics, and when I went to college in the late 80s, we were just starting to learn about object-oriented programming. And when I went to work for Microsoft and I worked in Microsoft Excel, none of the programs had object-oriented programming. We all programmed in C, and to be honest, it was extremely challenging to do so on large projects. Some of the greatest pieces of software ever written, like VisiCalc and then later Lotus 123 and Microsoft Word, which originated at Xerox PARC, all of those programs were written generally by single individuals. And really, one individual is best suited to write a large program with non-object-oriented programming. Because you have to know everything about, say, for example, a cell in Excel in order to be able to use any code that deals with cells. But we realized, or not we, but the industry realized we needed object-oriented programming to be able to deal with the software crisis. And there's a wonderful book mentioned in the Building Java Programs called The Mythical Man Month. If you like reading nonfiction books, it's a wonderful account of a software project which went terribly awry, but actually is extremely typical of software projects. And one thing I tell the students is that when you're done coding your project, you're only halfway there, okay? It's going to take another 50% of the time just to work out all those bugs. And if you try to add more people, the Mythical Man Month explains why when you add more people, instead of it taking a 12-month project then becoming 1 month because you added 12 people, it'll actually probably take more like 24 months. So by using objects, by using inheritance, we make things a lot simpler. We allow people to jump into a project late and be able to use code that's already been written without having to know very much about it. There are a few terms that we want to get straight about classes. One is the term is_a. So we say that a cat is a type of animal, and this is not a term that we actually use in the programming. There's no syntax in Java for this. It's just something that we use to refer to two different classes. We call the animal the superclass, and we call cat the subclass. There's another type of relationship called has_a. You can imagine that if we wanted to use this animal class in a zoo, for example, zoo would it has a animal. Okay, so we would populate the zoo with a bunch of animals. So that's a has_a relationship. But this basic one is called an is_a relationship. So by extending that superclass animal to the subclass cat, what we're going to be able to do is actually inherit all the state and behavior of the parent animal. So that will allow us to reuse code and avoid redundancy. The first thing we want to show you in Java is how you actually declare a subclass. So in Chapter 8, you learned how to declare a class. It would be public class animal, for example. Here, what we've done is we say public class cat. That's the subclass. And then we use the keyword extends animal. That's the superclass. So you must have already created a class animal, and then you're adding the new class cat. And then the member variable definition here looks just like in Chapter 8. Again, this is not a local variable like you would do for a static method, but this is rather a member variable. This is not actually creating anything at the time that the compiler encounters this code. This is it's a template for creating a cat object. And then here's a constructor similar to what you've seen in Chapter 8. But we have to talk about how to use constructors separately. The second main Java feature that we want to talk about in section 9.1 is overriding. So it doesn't show in this code here any actual functions, but imagine that the animal function has a method called getOffspring, and that function simply returns a string babies. So when you have a subclass for cat, you can then override getOffspring and return kittens. Or for a class frog, which would be a subclass of the superclass animal, it could return tadpoles, bird, it would return chicks. So what's the advantage of doing this rather than just having 4 separate classes? Well, presumably animal has some interesting functionality that each of these can inherit. Because if we just had getting the offspring and it was all different, that wouldn't be very useful. But we really assume that animal has some interesting things that we're going to inherit and that we're overriding the getOffspring method here. I think it's always useful to have a couple different examples, and I want to talk about the books example. What they have as a superclass is an employee class, and for subclasses they have different types of employees like a janitor, secretary, lawyer. And I think that's actually a little bit clearer example because an employee has they give some examples of useful employee information. So for example, they talk about hours and vacation days and vacation form. So what I'm going to do is drop into Eclipse and actually do an example with that employee class. But I'm going to intentionally not do the exact same thing as the book so that you can get a slightly different take on it. So I've created an employee class here, and let me go ahead and create the class definition. Public class employee, and then for my member variables, I'm going to have, let's go ahead and put, so let's, the book actually doesn't have any member variables in the superclass, which kind of annoys me because it's kind of a waste if you don't have something useful in the superclass. So I'm going to add a string name. So this is the employee name. For example, John Doe. And then I'm going to, let's go ahead and leap into having a function to get and set that. Public string get name. And that's just going to return this dot name. And now you probably realize that this dot is not required in this usage, but I always like to be very clear about what variables are, and I think especially beginners have troubles trying to figure out how do I just return name? Is that like the local variable that we declared up here? No, we're talking about classes. This is different. When a instance of the class is created, they get a member variable for name, and then I'm returning this, meaning that object's name. And then similarly, we're going to do public void set name with a string name. Now in this case, we have to use this dot name equals name. And again, just as a review, this dot name, it refers to the object's name, and this name refers to the parameter passed in here. Okay, so, and then of course we need a constructor. So we're going to do public employee, and the employee here signals that this is actually a constructor. And we could do a empty constructor, but I don't think it's really useful, because why would you construct an employee without a name? You wouldn't do that. So we're actually going to give it a string name. And then what I'm actually going to do is let's go ahead and call set name with name. I could have just done this exact same code here, but why don't we take advantage of code reuse, right? So this is my constructor. These are my getters and setters. All right, so that's my class employee. So the error here is reminding me that I actually, normally what I would do is create like some sort of a client for the whole file, and then I would put the class in here. So I'm just going to get rid of, it's complaining that I'm nesting employee inside employee, right? Which is true. I'm not supposed to be nesting. I'm going to get rid of this outer set of brackets. And then I'm going to re-tabify this. Great feature. You should get used to doing that. In Eclipse, you can do source correct indentation, Control I. Oops, let's try it again. Control I, and that corrects that. All right, so I've got this class here, but I still need to actually call it from somebody in order to try doing it. What I'm actually going to do is create a new class, test, and note that I'm not going to put public in here because Java won't let you create two public classes, but you can create as many non-public classes as you want. And then in here, we'll do our main. And inside here, we're going to create a new employee. New Okay, so we created a new employee. And then we're going to do a system out. By the way, that I used control space to generate that full sysout of E. Now, I think what it's, oh, well, okay, I'll go ahead and show you the error that we have. I'll go ahead and run it. So I hit Control F11. All right, let me bring this console window down here. Okay, so what it printed out was this wonderful thing, employee at blah. And this is the default behavior in Java, because if you don't create your own toString, it's just going to give you, this is actually a memory address inside the computer of where the object is. So this is an excellent segue to talk about that subclassing. So what we can do is we can define public our own toString. So I know that toString is of the form, it just returns a public. It's called toString takes no parameters, and it does a return of, you create the string that you want it to return. Now, in this case, we just have a name. That's all that I need, but I'm actually going to make it a little bit better, and I'm going to say employee colon, and I was thinking about, should I put quotes in there? No, I won't put any quotes. I'll just put employee quote colon, and then follow it by name. Okay, so now what happens when I run this? Now it says employee colon John Doe 1. Okay, so, and by the way, you notice that Eclipse automatically added the @override. That is a compiler flag that adds some additional compile time checking to verify that you really did override the function. And in the reverse, if you don't put @override, it will automatically look and see if you are overriding a function. Now, let me go back a step, and let's get rid of that @override. And let's say that well, let's see, let's say that I misspelled it, okay? I used toString. Now what did this do? Let's try running it. Notice it went back to the old format. That's because I didn't actually override toString. It thinks that I added a new, entirely different function called toString, no capitalization, okay? But in the object class, so all objects in Java inherit from what's called the object class, and the object class has toString and equals in it. And in order to override that function, you have to use the exact same format. You can't add any additional parameters here. It's got to be the same number of parameters, the same return type. And now when I run this, you'll see Java is going to insert that @override because it notices that I did actually override the function, and it's got employee here. So that's overriding a built-in object class. Now let's go and actually override a real function. So the employee class, the only thing it had was the name. Let's add something similar to the book, and let's say let's create an integer for hours. Okay, and this is the hours worked per week. Okay, and let's set the default constructor. Well, let's do the getters and the setters first. So let's have a public int get hours, return again this dot hours. It's not totally required, but I always like to use that. And then the setter public void set hours, and we actually need to provide the hours now. And we'll just do this dot hours equals hours. Okay, so we got the getters and the setters. And now let's go back up to the constructor. So the constructor, here's a case where we can actually have a default, even though we didn't specify. Generally, people work 40 hours a week, so we will do set hours of 40. Okay, and so now let's change our calling, our client. Let me make a little more room here. We don't really need that much. Okay, so the client is, well, let's change the toString, right? The toString, let's add just thinking of how do I want to print this. Let's just put same way, hours colon, and I made a mistake because I should have said here, I'll actually do this. I'll do get hours. Okay, where I used name here, this should have been this dot name, but even better, get name. Okay, so now let's run this again, and now it says employee John Doe hours 40. Okay, so so we've already shown subclassing within just one class. Now let's actually create the subclass. So what's an example subclass that the book used? Secretary, right? So let's create a secretary class down here. So this is for the employee class. So now let's do class secretary extends employee. And so the first thing we have to do is create the constructor. So we're going to do public secretary. And what are the parameters for secretary? We're going to need a name again. So let's do string. Now, what we want to do is we want to initialize all the fields of an employee first. And the special way you do that, and we're jumping ahead, is to do a super of the name. So the super is from section 9.2. We're getting ahead of ourselves, so I'll skip that, explaining that for now. But let me make it a little more interesting by adding a field for the secretary. So for the secretary, let's say that secretaries have, okay, we're going to be, old school, say words per minute, okay? So let's have an int, private int, words per minute. Let's just call it WPM, right? Okay, so words per minute, and let's do a public, we're going to get a getter and setter, so public int get WPM, no arguments, return this dot WPM, and a setter this dot WPM equals WPM. Right, now we can actually set. So let's be clear about this. This is the superclass employee constructor. Okay, so that is going to set the name of like an employee. Now, secretary specific constructor. So let's set WPM to a default. What's a default? It's been so long. I think like 80 words per minute might be an average speed for typing. And then, of course, we still need a toString. So we're going to do public string toString. So here's another example here where I'm going to use the superclasses definition, super dot toString. So that's going to print it out like this. But we're also going to add in the WPM colon and get WPM. So we're going to actually inherit the functionality of the employee class, but we're overriding it to add in WPM. So if I just ran this now, we would get the exact same thing. Why? Because, well, we only created an employee here. So now we've got to deal with the subclass. So now we're going to declare a secretary. So I can actually declare a secretary or an employee. First, I'll declare it as a secretary. We're going to do a couple of ways. So I'm going to call it S1 equals new secretary. And let's not be sexist, so let's call him Mike Jones. Okay, so we have a new secretary, and then let's print out S1. Okay, let's try running that. Okay, so secretary Mike Jones types 40 words per. Well, we need some spacing right here. We need to put a little space. Space word per minute. Quickly try rerunning that. There we go. They work 40 hours per week and they type 80 words per minute. So that's an example of overriding a function. So at this point, I would suggest you stop this video and do Chapter 9, questions, Section 9.1, questions 1, 2, and 3 from Section 9.1. And so the first question is about code reuse. We talked about code reuse. And let's take example of, in this example, how are we reusing code? Well, we're creating this secretary, and we didn't have to know anything about how the employee name is stored or how many hours per week is stored, and we didn't know how to create the string to represent the employee. We're using all of that, reusing that code instead. There's a question about overloading versus overriding. So here's an override. So in the object class, we never looked at the code for the object class because it's not provided to you. But in the object class, somewhere in Java's definition, they have this exact same definition of a function called toString with no parameters, called toString with a capital S and returning a type string. That's overriding. And you override a member of your superclass. Now, loading is a concept that we learned in CS 142. Just to remind you, so for example, I can overload the function setWPM. I can create another version of setWPM, but I have to change it in some subtle way. Not in the name, but in the type of parameters, either the input or the output. I'm going to leave it as a void, but let's take a string, WPM as string, okay? And then what I would have to do here is code to convert string to an int, okay? Then I could call, you can do whatever you want, but what I would probably do is set WPM of that, let's call it I, okay? So we have to create a local int I that will hold the conversion of WPA as string into an integer I, and then I would call set WPM I. So overloading is when we have two functions with the same name but have different signatures. So that's the input or output variables, and they perform different functions, but you can call you can use the same word in the code, but they actually call different functions, all right? That's overloading. Let me get rid of this code here so we don't confuse ourselves in the future. Versus overriding, where it's the exact same signature, not only the same name, but the same input and the same output. And then what we're doing is it's not going to call it is going to call a separate function, but it's going to take advantage of the superclasses function as well. And then the third question is simply this format of how do you declare a subclass extending a superclass. So try section 9.1 questions 1, 2, and 3.